Hello and welcome everyone. So let's have a look at this example here. This is the top example on the handout for this particular lesson here. So I'd like you to focus on this and just sort of plan it out in your head here. So first thing we want to do is we want to show that QRU and TSU happen to be similar triangles here. Now remember that one of the things that we are equipped with at this point is the angle-angle postulate. We know that that is true. So in this case here, all we need to do is find two pairs of congruent corresponding angles. Now, considering the picture, that's not too hard and the information that's given to us here. So one of the first things you may notice that, RS is perpendicular to RQ, RS is perpendicular to TS here. So that gives us two congruent right angles here, right? That gives us right angle here at R and a right angle here at S. So that's going to be important here. So we can mark those. That's one pair of angles that we're going to use. And then we have a second pair of angles because we were told that these two angles intersect at these two segments intersect at U. We have a pair of vertical angles here. So it looks like I've got myself my angle. So let's go ahead and write this one out here, okay? So now that we have this, let's go ahead and write this out. Let's not worry about the follow-up just yet. We'll just go ahead and write this out here. So I'm going to write this out into column form to make this a little easier for ourselves. Okay. Here's our statements. Here's our reasons. Okay, so in this case here, writing this out should be very easy considering we've had a lot of practice with proofs in the fall term. So let's go ahead and write this out here. So in this case, we want angle-angle, so we're going to have to go ahead and introduce our givens. So in this case, I'm going to be using RS and RQ and RS and TS because of the fact that they both generate the right congruent right angles we need. So I'm going to list them together here. Normally, I don't like doing this, but because I'm using the same thing on them, I'm going to do that here. So we can say that angle R and angle S are right angles here. And here, this is just our definition of perpendicular lines, right? Because we know that they are perpendicular from step one. Right? And now we know that angle R is congruent to angle S here. And because I know I'm going to be using angle-angle postulate, I'm actually going to write out I'm going to mark it as if it were a congruence proof. Right, so I can do this something like this here, and we can say in this case here, all right angles are congruent. And that's step 2. Excuse me, ladies and gentlemen. Okay, so now we can move on to the next pair. If we look back at our picture on top, we saw that we have vertical angles here, and we know they're vertical angles because we have two intersecting segments here. So I'm going to go ahead and introduce that. So we can see that RS and TQ intersect at U, and that's given to us here, right? And we can keep going from this here. Now we know that angle RUQ is congruent to angle SUT, and that's another pair of angles here. And here we have our vertical angle, so we can say vertical angles are congruent. And that's from step 4, right? So we know that we have that here. Okay, and now we can go ahead and prove the triangles are similar because we have our two pairs of angles. So we can say that QRU is similar to triangle TSU here, and that's because our angle-angle postulate. And that should be from steps, if you remember here, it's from steps 3 and 5. Wonderful. So our proof here, as you can see, works very nicely, and it works just as if we were doing a congruence triangle proof. But now let's go to the follow-up here, okay? So we're given that RU is 10, SU is 15, and QU is 20. We want to find TU. All right. Well, there are quite a few proportions that we can use here. It looks like we have similar triangles here. So it seems that a proportion is necessary here. So we note that the 10 and 15 here. So one proportion we can write is something like this: 15 over 10 equals TU over 20 here. Now, how do you know that? Why is this true here? Well, let's take a look. We know that SU and RU here, they're both opposite this red angle here. So if I mark this angle in red, they're both congruent, these are congruent corresponding angles. So RU and SU are in correspondence here, right? And similarly, TU and QU are both hypotenuses of the triangle. They're both opposite congruent angles, so they correspond as well. So, by matching up the corresponding sides with each other, we kind of have this sort of thing here. And as a result, we can kind of write this out. So we can, do our multiplication here. We get 10 times TU equals 15 times 20 here. So in this case, TU is equal to 300 over 10, which I think is 30. So you find that TU is equal to 30 here, which is, pretty sensible considering what all things considered here. Now, I want to go back to this here, right? Because we have 15 over 10 equals t over 20. So we knew those things met. Now, if we go back and take a look at what's going on here, this we can rewrite in terms of the segments, right? So, for instance, here, I can write this. So we know tu's up here. In this case, 20. Well, 20, that's qu here. I can write that. And us is 15. And that's u. So I can write this as us here. And 10 in this case is ru, right? So notice that what we can have here is we have ourselves a proportion like this. us over ru equals tu over qu here. So in the same fashion, we can go ahead and write this in here. So in fact, considering that we have this is a result of the fact that the triangles are similar. So as a result, I can actually include this as an additional step in my proof here. So I can write as step 7 here that us over ru equals tu over qu here. Now, why is that the case? Well, in this case, notice that, if this were a congruent triangle thing, we would say that corresponding parts of congruent triangles are congruent. But now we have to be kind of careful here because there's no congruence. Right now we have we're equal ratios here. And what's in equal ratios? The sides. So you can very easily, adapt the statement that we had in congruent triangles for similar triangles here. So we can say that corresponding sides of similar triangles are in proportion. And notice that comes directly from step 6 here. So this allows us to get to that, right? This allows us to get to this here. So we can go from here to here. Now, that seems great. That's wonderful. But also note, ladies and gentlemen, note that, in this situation, solving for TU, we didn't, yes, we used a proportion, but there was also something else we used here, right? Notice how we were able to convert this from 15 over 10 equals T over 20 to this here, that 10 TU equals 15 times 20 here. We were able to convert this statement to this statement here, and this, you may recall from our first lesson here, this is something we talked about before. We had a proportion, and we have the fact that in this case here, the means and the extremes, the product we know is equal here. So, in fact, that actually gives us one more statement in proofs here. We can actually continue to this here. And we can prove in a further step, step 8 here, right, that we can say in this case here, we can write that QU times SU equals RU times TU here, right? And we can say that in a proportion, the product of the means equals the product of the extremes. And that's from step 7 here. So notice here that, in essence, what we have here, ladies and gentlemen, is this proof of similarity here. And we can extend it and do further things based on that here. Much like how with congruent triangles, we were able to prove specific things were congruent. And as a result, we have an angle bisector or a midpoint, something like that. The same idea is true here. So now what we can do here is, considering similar triangles, we can now show that a specific product of segments is going to be true. Part of looking at something like that here, if you're looking at a problem like that, now part of it is just sort of, try to build backwards. Go from this, go back to what the proportion would have been that led you to the product, and then see, okay, if I got a proportion, that means I've got similar triangles. So which triangles are similar? Which side, what correspondences can I find here? And we can try to find ourselves some similar triangles. And that is going to help you for this sort of thing here. So remember that when you're trying to prove that a specific thing has a product is true, try to look for similar triangles and try to, build this backward from the goal.